Hi everyone, my name is Grace Hansen, and we just mentioned in my intro, I'm an intern on the Fulfillment Monitor team this summer. This fall, I will be a sophomore at the University of Minnesota, where in my free time, I will be studying trees or Dendrochronology. Today during this presentation, I'm going to talk to you about trees and what Dendrochronology is. And at the very end, I'm going to make a connection between SPS and my research at the University of Minnesota. So to get started here, I'm going to tell you what is Dendrochronology. That is a perfectly fair question because every single time I tell people about my research at the University of Minnesota, they ask me what this word is. And to give you a definition, I'm going to break it into two parts. The first part is dendro, which comes from the Greek word dendron, meaning tree. And the second part of the word chronology means the study of time in Latin. So when you put these two concepts together, you get that dendrochronology is the study of growth in trees over time, or more specifically, the study of growth rings in trees over time. Growth rings are what you see when you cut a tree in half and you get like a slice of it. It's an array of concentric circles. And each pair of concentric circles represents 1 year of growth in that tree's life. Here's an example image showing you what it would look like if you took a slice of a tree or looked at a tree stump out in the forest. You can see that array of concentric circles I was talking about, and I said that each pair of concentric circles represents 1 year of growth in that tree's life. The pair includes a lighter portion right here and a darker portion right outside it. The lighter portion is called early wood, and this means that the wood grew during the early half of the year, and the darker portion is called late wood, and that grew during the latter half of the year. What's interesting about trees and the way they grow is that trees not only grow vertically, like you'd normally think, but they also grow radially outward, meaning that they start in here with the oldest growth rings at the center, and they continue to add layers and become thicker as they grow older. So the newest, youngest growth rings are near the bark out farthest away from the center. Now, looking at a slice of tree like this is really cool, but if dendrochronologists cut down a tree every single time they wanted to study its history, that wouldn't be very sustainable. So there has to be other ways in order to collect samples of these trees without killing them. And there is. What we use is called an increment borer tool. This tool over here on the right gives you a better image of what it looks like, but it looks like a long drill bit with threads at the very end and a handle on the opposite side. And what you do in order to extract a tree core sample is you take this long drill bit and you press it up against the side of a tree and start turning clockwise in order to drill to the very center. Once you reach the center, you can back out the drill bit by turning left and eventually pull out the extracting tool at the very end. This extracting tool allows you to pull this core sample away from the rest of the tree and reveal a huge set of rings, again, without killing or hurting the tree. So it's pretty awesome. In this picture here, you can see a tree core sample that was just extracted from the tree. The bark of the tree is near the left, near the person's hand, and the older rings are near the handle down here. Once we get this tree core sample back to the lab at the University of Minnesota, we can then begin to analyze it. And dendrochronologists do this in two main ways. The first being that they manually count every single ring on the tree in order to figure out how old that tree was when we took the sample. And the second way is to take a piece of graph paper, like you see in this picture here, and mark on the graph paper lines or the rings that are abnormally thin. When a tree ring is abnormally thin, this means that they didn't receive the right amount of resources compared to other years. This could mean a lack of sunlight, a drought, or extremely cold temperatures, and this would make the tree grow less and have thinner rings. And what they do with these pieces of graph paper then is compare the graph paper from multiple samples, and then they're able to make generalizations about the climate in the past so that we can learn about how this has affected trees and eventually make predictions about the climate in the future. As you may notice from this picture here though, it's pretty difficult to discern where one tree ring begins and the other one ends because they're really small. So what dendrochronologists have been doing for over a century is using microscopes to individually look at these tree rings and try to discern which ones are thinner than usual. And again, this is still really tedious, and there's really no accurate or precise way of measuring the width of these tree rings, which is a huge gap in the data that we could collect and learn about these trees. So my professor, Daniel Griffin at the University of Minnesota, the lab that I work at, noticed this gap about a couple years ago and started developing a tool called Dendro-Elevator. This tool takes high definition photos of tree core samples, like the one you see here, and allows dendrochronologist researchers to plot points along the core, automatically measuring the distance between these rings. And right now I'm going to give you a quick demo of what that tool looks like. So can everyone still see the screen with the tree core on it? Cool. This right here is an example of a tree core sample inside the Dendro-Elevator tool. This is actually the first tree core sample that I took in January with Griffin Labs. And if we start over here near the left side of the tree and I zoom in, you can see right here is some of the oldest rings in the tree. And you can tell this because the curvature of the ring starts to get more evident. And that is because as you get near the center, the radius of the circles of the growth rings get smaller, so you can see more of the circle as you get farther into the center of the tree. Now I'm going to go out to the other side of the sample, which includes the bark. Right here is the bark, and these are the latest or youngest growth rings. As you can see, it's pretty difficult to actually tell where one ring begins and the next one ends and the next begins. But dendrochronologists are fairly good at telling where these end and begin, and it just comes with practice. Is what I learned. But now I'm going to add the points back on so you can actually see where we've gone in and marked the different years. And what's cool about this software is that once you add all of these points in and give it the year that you took the sample in, this was 2020 for this tree ring, it will automatically go through and edit the other points so that you know what year that the tree ring happened in. So like if I go all the way over to the other side of the screen and hover over it, it'll tell us that that ring was from 2014. And as you may have guessed, including just going back a few years, I can go back all the way and tell you how old this tree actually is without having to manually count and remember what year I'm on. So here's the earliest years of growth, and I'm going to hover over the earliest point. And this tree actually started growing in 1865, which is when the Civil War ended. So that gives you a little bit of perspective on how old this tree is and how much data we can actually learn about our climate in the past. So that was a quick demo of the Dendro-Elevator tool. And I'm going to jump back to my presentation slides here and tell you more about how this relates to SPS, like I promised at the beginning of the presentation. So in January, like I said, I took my first tree core sample that I just showed you. And this is a picture of me coring the tree. And this is the nearly 160-year-old tree, which doesn't look very old from the picture, but is actually that old. And at that time, I really wanted to work on the Dendro-Elevator tool and continue to develop it, but I had no concept of how to write in JavaScript, the language that the Dendro-Elevator tool is coded in. But luckily for me, only a few weeks later, SPS came back and offered me my internship for this summer, where I would be working on the fulfillment monitor team and writing code in JavaScript. So I was super excited, not only for interning at SPS, but getting an opportunity to work with this research group in the fall to develop their tool. So to give you a little bit more history of my work here at SPS, over the past 7 weeks, I've been working on the fulfillment monitor team, learning JavaScript. From the beginning, I felt like a full member of their team. They were super welcoming, and I loved them from the very beginning. I was able to participate in their agile process by listening at planning meetings, receiving tickets, completing them, and then going through the review process in order to merge it into the main branch of code. Now, I'm going to take what I've learned here at SPS and apply it to the Dendro-Elevator tool and further improve it in the fall. So this research is going to give us a record of how climate change has affected our trees, as well as how we can manage natural resources and combat global warming in the future. So in the end, the connection is really simple. By creating internship programs and teaching students, SPS gives the students an opportunity to grow professionally as well as in their university communities. So they've even given students like me an opportunity to grow with trees. Thank you everyone for listening to my presentation, and thank you to everyone here at SPS.